Hey guys, we're going to talk about harmonics today. I just pulled this up. I googled harmonics, and this is what came up. You get all these cool little patterns. So harmonics is all about trapping waves between boundaries. You get these cool patterns that are set up inside of those boundaries, whatever they may be. And these are actually musical notes. This is how music's made. So this is what we'll be talking about. Of course, I'd have all these cool demos, and we do amazing labs, and if we were in class. Sorry, we're not. So, how do you get harmonics? Well, you have to trap waves. I have this video, and I don't think you can hear it, doesn't matter. But we would have done this lab in class. This is a string, and if you trap the waves, they bounce back and forth between these two boundaries here. You get these different patterns that are set up. This is called the second harmonic, right? These are called standing waves, and they're waves that are trapped and they just bounce back and forth, and you get these different patterns. And of course, these different patterns would be musical notes. And I show this video in class. You can't hear it, even if the sound's on. But anyway, this guy, he put his iPhone inside of his his guitar, and get these cool patterns. And so that's what we're talking about. We're actually just talking about making waves. And so all these patterns mean something, right? So you get all these patterns. These are all different notes. And you can probably guess, these are low notes up here, and these are high notes down there. And so this is the way this works. So here's the thing I use to teach with. And so I was just going to use this thing. And so this is if you stand the string up, right, in a vertical sense, and you pluck it, boing, then the string vibrates back and forth like this, and you get waves that are going back and forth, up and down. You get these patterns. This first big one here is called the fundamental, and all the other patterns are based off of the fundamental. And then you have the second harmonic, then the third harmonic, then the fourth. And you get the picture, right? Now, let me go back to this video. The parts that move back and forth right here, this is called the antinode. It's hard to say. And this is the part that actually vibrates back and forth. So the second harmonic has two antinodes. This part right here in the middle doesn't actually move. And there are actually three places on this trap string that don't move. Over here, and right here. So you have these three places. And so these are called nodes, where the string doesn't move. Those are called nodes. Let me go back here, right? So here's your second harmonic. It has 1, 2, 3 nodes. 1, 2, 3 nodes. This part that goes back and forth in this part, those are called antinodes. I don't ever call them that. It's hard for me to say. I call them loops or bumps or hills. In this video, I think this person called them loops. So your fundamental has 1 loop. Your second harmonic, they say, has 2 loops. Your third harmonic will have 3 loops. And these are different notes. Okay. The more loops you get, that just means you're cramming more and more waves into a smaller space. Right? And so what happens here, these are your low notes on the left, and then as you go this way, you get the higher notes on the right. You're cramming more waves in, right? So all those little waves are going to move really, really fast, and the frequency goes up. Okay. So this is what a harmonic series looks like. And here again, if I Google this, I just get a bunch of the same stuff. I get a lot of stuff that, you get all these funky little pictures. These are harmonic series. These are all different series of notes, right? So if you look on the left side here, you have your fundamental, which it says it's 6 hertz. That is the frequency of the waves. Now, your second harmonic, you're now cramming in more waves, okay? And so 6 times 2 gives you 12 hertz. So to go from the fundamental to the second, you take whatever your fundamental is, and you multiply by whatever the harmonic is. So 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. If you want to know the sixth, you go 6 times 6 is 36. So going from fundamental to each harmonic is pretty easy. You just multiply by whatever harmonic you want. Now, if you want to go backwards, you can do that. So if we're at the fifth harmonic, and you want to go back to your fundamental, you take the fifth, which is 30 here, and divide by 5. 30 divided by 5 is 6. So there you go. So on this right side here, the second harmonic is 20. So the fundamental would be 10. Your third harmonic would be 10 times 3, which is 30. Your fourth would be 10 times 4, which is 40. So you get the picture here. You can go back and forth, and it's just a neat little pattern. I know y'all can do this because my freshmen can. And I know if they can do it, y'all can do it. Not a big deal. Now, the harder part is talking about lengths of things, right? So, what is a wave? A wave is a repeated part of a motion. Every 2 loops is equal to 1 wave, or 2 bumps, or 2 hills. So your second harmonic is exactly 1 wavelength long. So this is a wave. And then as you go, your waves get smaller. So your waves are getting smaller and smaller and smaller as you move from left to right. You're cramming more waves in there. You're cramming them more, so they have to get smaller and smaller and smaller. So those notes are getting higher and higher and higher and higher. Okay. Now, the symbol is something called lambda, which is this little thing right here. And so what happens here is the hard part that students, the hardest part that students have trouble with is understanding the difference between length of the wave and length of the string. Okay, so we're going to talk about that here in just a second. Okay, guys, so I'm hoping this is working. So if you look at this behind me here, this is a harmonic series, right? Got the fundamental, second harmonic, third harmonic, fourth, fifth, and of course there's more, but I don't need to draw so many. Okay, so the way this works is every 2 loops is equal to 1 wave. So the second harmonic is the only one where the length of the wave and the length of the string are the same. So what these are actually strings that are attached top and bottom, and then we pluck on them and they vibrate back and forth, right? The second harmonic is the only one where the length of the wave, the length of the string are the same. Length of a wave is called lambda. It's a Greek letter, lambda. That's the length of a wave. Now that's different from L, which is the length of your string. Okay. Second harmonic is the only one where your wave, the length of the wave, is exactly the same as the length of the string. So there's the length of our wave right there. Okay. Now what happens is as you cram more waves in, as this stuff's vibrating back and forth really, really fast, your wavelength, so there's lambda there, your wavelength gets short. See what happens to lambda here. It's getting really small up here. Can you draw that? So lambda's getting really, really small. As you cram more and more waves in here, wavelength gets smaller, 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 smaller. Those waves are getting higher and higher and higher, and those are really high notes. Okay, so there is a pattern here, and it's been included in the Canvas module, but here it is. The second harmonic is the only one where, if y'all can see this or not, but lambda and L are the same. The first harmonic or your fundamental, you would need a whole nother big wave. You would need a whole nother loop here, right, to get a full wave. A wave is 2 loops. So you would actually need double the length of your string. You would need 2L. You need double the length of your string to get a full wave here. So the length of the wave needs to be 2L. For the second harmonic, the length of the wave is the same as L, the length of the string. For the third harmonic, the length of your wave is 2 of the 3 total. So lambda is 2/3 of L, or 2/3 of the total. For your fourth, it's 2 of the 4. So your length of your wave is 2/4 of L. And then for your fifth, length of your wave is getting real small. It's 2 of the total 5. So that's why it's 2/5 L. And that's the pattern. So if we have our sixth, it would be 2/6 L. If we were a seventh, it would be 2/7 L. If we were eighth, it would be 2/8 L. And that's just how this works. And I hope that makes sense. So as you cram in more waves in, the wave itself gets smaller and smaller, which means it's becoming a smaller and smaller fraction of the length of the string. So L is the length of your string. Lambda is the length of the wave. Some questions will ask you to find lambda. Some questions will ask you to find L. And so that is the math here. Let me see if I can switch this back to... all right. So that's how this works. Now here's the deal. We have strings. And so that's what I'm showing you here. So you can make music on strings. You pluck strings. And you guys playing, string instruments, that your string is attached at 2 places, right? And those waves bounce back and forth, and you get all these cool patterns. And that's what happens. You can also have what are called tubes. Where are they? Here they are. These are called your tubes. You have open tubes and closed tubes. Open tubes are open at both ends. So here is a progression of open tubes. They are open at both ends. Closed tubes where one end is closed. And of course we would have done labs for this in class too. Now the good news is that all the math for your strings and your open tubes is the same. The patterns end up being the same. I'm wondering if you can see that. Here is the fundamental up here. This is the fundamental for an open tube. I'm hoping you can see that this pattern is really the same as this thing. Okay? Or let me show you another one. Like this guy right here is your fundamental for the string, right? And here is the fundamental for an open tube. They're the same. You get the same pattern. Closed tubes, however, are a little different. Okay? So, here's the math. Here's first, second, third. You've got 2L, got L, you've got 2/3 L, then you've had 2/4 L, then you've had 2/5 L. So you see how the math there is the same as what I was showing you on my board. For closed tubes, this waveform here is only a quarter now. So now the length of the wave would need to be 4L. So lambda would be 4L. For the second harmonic, lambda would be 4/3 L. For the next harmonic, it would be 4/5 L. And actually, this is not the second harmonic. It's called the third. I'm not sure what's going on there. That's interesting. Dadgummit. Because I found something wacky. Here we go. So this is your fundamental. It's 4L. This is called your third harmonic. It actually skips. So you have the first harmonic, third harmonic, fifth. And that's how that works. So these are, for strings, you get even numbers, and for tubes, you get odd. All right, we're going to try some practice problems here in a second. You may have to watch that again.